Hi friends, let's see a practice question on basis. So this is our question. We have three vectors here and we have a vector space, and we need to show that these three vectors form a basis of our vector space R3. So the dimension is already given. The dimension of this R3 is 3 and we already have three vectors. So nothing much to prove here. We just need to show that all these three vectors are linearly independent. Okay, since the collection of vectors that is present in basis are linearly independent and the number of vectors that are present in basis are same in numbers as the dimension of the vector space. So we need only to prove that these vectors 1 2 1 2 1 0 1 minus 1 and 2, they are linearly independent. If we can show that these vectors are linearly independent, then we can easily say that this forms a basis of R3. So anyway, tell me what will be the standard basis of R3. Okay, just write the standard basis of R3 in comment section. Okay, so it's actually very simple. Let me tell you that the standard basis of R3 will be the columns of standard, the columns of the identity matrix. This will be the standard basis or natural basis of R3. Okay. So in order to show that these three vectors are linearly independent, we need to we have already seen two methods. One was by using Gauss elimination method. So basically this is not a method that is specific in showing set of vectors linearly independent. It is a method to solve a system of linear equation. So, and another was by using determinant method. Okay, let me revisit the definition here. So if we are saying that these vectors are linearly independent, what does it mean? It means that if we have some constants or some elements from field, so what will be the field of this vector space? This is R3. It means that the field is R. So basically it can be written as R, or you can write it like this also. Okay, so the field is R itself. So if we have three elements A1, A2 and A3 from the field R, then the equation, what was the second vector? Then the equation A1 multiplied by the first vector, say V1, A2 multiplied by the second vector, say V2, A3 multiplied by the third vector, say V3, is equals to 0. This equation, if these V1, V2 and V3, this and this vectors, these vectors are linearly independent, then there will be only one solution, and the solution will be A1 equals to A2 equals to A3 equals to 0. If we can find any other solution that is different than this solution, then we can say that these vectors are not linearly independent. It means that these vectors are linearly dependent. So if these vectors are linearly dependent, then they will not form the basis of R3. Because if these three vectors are linearly dependent, it means that any one vector, at least any one of these vectors can be expressed in the form of another vectors, and we already know that the basis contains linearly independent vectors, and the number of linearly independent vectors contained in the basis should be equals to the dimension of the vector space. And here, what is the dimension of the vector space? The dimension is 3. Okay, so it is required that we should have 3 elements in the basis, and since we are given with the 3 vectors, it is required that these 3 vectors should be linearly independent in order to form a basis of R3, right? So let's solve this, and let's try to find out the values of A1, A2 and A3. This system, this equation can be written as a system of equation we have our elements here. Look, this representation is very important. Via this representation, you can solve this system by using your Gauss elimination method, or by matrix method, or determinant method. Let me talk about this determinant method. So if we consider that this is a matrix A, then if we find the determinant of matrix A and it is equals to 0, it means that these 3 vectors are linearly dependent. Okay, it means that these vectors are not linearly independent, they are linearly dependent. And if we have determinant A not equals to 0, then we can say that the vectors are linearly independent, right? So you can solve it in either way. Just calculate the determinant. If it is non-zero, then you can say that okay, the whole the collection of vectors is linearly independent. So obviously if these vectors are linearly independent, then they form the basis of our R3, right? But we'll use this Gauss elimination method. So we have our matrix. So first we'll perform some elementary row operations to reduce this matrix. So let's say R3 equals to R3 minus R1 and R2 equals to R2 minus 2 into R1. What this will give? This will give us 1, 2, 1, 0. R2 minus 2R1 minus 3. R2 minus 2R1 will give minus 3. This will become 0. This will become minus 2. This will become 1. Okay, so we got this. Right? When you are reducing this any matrix, perform the operation so that in the first step you get these two values as 0. So basically what we are doing, we are converting this matrix into row reduced form or Euclidean form. Okay, so if you are reducing any matrix to Euclidean form or row reduced form, try to perform the operation so that you get the values that are immediate to the first element of the matrix as 0. So these values, your target should be these values, to make these values 0. And in the second iteration, your target should be this value, to make this value as 0. So in the first target, in the first step we got these values 0. Now our aim is to make this 0. Okay, so first let's make this element here as 1. So see, R2 equals to minus 1 upon 3 R2. Okay, so what we'll get? We'll get 1 2 1 0 1 1 0 minus 2 1. Okay, okay, next thing, so this was the second step, this was the first step, this is the third. Okay, so next what we'll do, we'll say R3 equals to 2 into R1, 2 into R2 plus R3. Okay, so we'll get 1 2 1 0 1 1 0, this will become 0 and this will become 3. A1 A2 A3 to 0 0 0, and what this means that 3A3 equals to 0 implies A3 equals to 0, and A2 plus A3 equals to 0 means A2 plus 0 equals to 0, which means A2 equals to 0, and A1. So basically what we are doing, first we are using this, then we are using this, then we are using this. So first this is multiplied by this, so we got A3 equals to 0, then this is multiplied by this, we got A2 equals to 0, now this is being multiplied by this, so A1 plus 2 A2 plus A3 equals to 0, and since A2 and A3 are already 0, so A1 implies A1 equals to 0. So what we have now, we have our A1, A2 and A3 are nothing but 0 0 0, and this is the only solution we have. We solved the equation by using our Gauss elimination method, and we saw that this particular equation A1 V1 plus A2 V2 plus A3 V3, where these are the vectors that are given in our question, is equals to 0 only when all are AI equals to 0, where I equals to 1 2 and 3, and this is the condition for linearly independent vectors. So all these three vectors here, all these three vectors are linearly independent, and since the dimension of R3 is 3 and we have 3 linearly independent vectors from R3, then we can say that this forms the basis. So this forms the basis. Okay, so in the conclusion you can write it like so: this vector forms basis of R3, right? And this is solved. So what we have seen, we can use these two methods to prove whether the given set of vectors are linearly independent or not. And if we have some problem like this, first look at the dimension. The dimension was 3 and 3 vectors from R3 are already given, So we need to show that these vectors are linearly independent or not. If they are independent, then they will form the basis of R3. Okay, and if they are not independent, then we have nothing to prove. We can say that at least one of these vectors can be expressed in the form of, or in linear combination of other two vectors. So they are not linearly independent. It means that they cannot form a basis of R3, right? So this was a basic, very simple example. Don't worry, we'll take some examples from previous year question papers also. So just hold on to this channel, because there are lot of the things that are coming, and we'll be discussing the things again when we'll solve the previous year question papers. So thanks, and please subscribe the channel and share these videos so that they can also get benefited. Bye.